Hello and welcome to episode 19 of Chemistry in 15 Minutes or Less. My name is Audra and this review lesson is on chapter 22, part 3, Functional Groups. Now a functional group is an atom or group of atoms that is responsible for the specific properties of an organic compound. And just for some brief things that will come up while we go through this, if I write an R just stands for any sort of organic chain. That could be like something as simple as methane, or it could be something really, really long like hexane or nonane. But it just symbolizes an organic chain. And two terms you'll hear me throw around a lot are terminal carbon, that means a carbon on the end of a chain, and an interior carbon, which is a carbon within a chain. Now there are a couple of main types of side groups that we will be going over. Alcohols, alkyl halides, ethers, aldehydes, and they go with ketones, carboxylic acids, esters, and amine groups. We will go over these in order, so let's start with the alcohols. Now, the alcohols are organic compounds that contain one or more hydroxyl groups. Now, a hydroxyl group is an OH group, which looks like hydroxide, which is why it's called a hydroxyl group. Now, to name an alcohol, you must give it the OL ending instead of, for example, your ANE of an alkane. Now, the ending must be modified also to show the number of hydroxyl groups. Now, these will be the same prefixes to your suffixes that you saw in the alkenes and the alkynes, where you'd say something like a diol, triol, and so forth down the line. And these are used as fuels or moisturizers, and the general formula for these look like this with an organic chain and then the hydroxyl group. Most importantly, this is bonded to the oxygen, not to the hydrogen, because the hydrogen can really only form the one bond. Next up on our list, we have the alkyl halides. Now basically, these are organic compounds in which a halogen is subbed in for a hydrogen, somewhere in the chain. They are just like alkanes, but halogens are used for the subgroup names as far as naming goes, and you can use X if you don't know which halogen it is. So the general formula for these looks like this, with an organic chain to a halogen, which would be something like chlorine or fluorine or iodine or bromine. Now these are used as solvents and reactants. So you just name them like a normal side group, like if you have 3 carbons, say a chlorine, and then the rest is filled in with hydrogens. You have 3, which means your group is propane. So this would be chloropropane. Now you will need to put in a position number since this could be on any one of them, so it would be 1 chloropropane. Just for that specific example. Next subgroup is called ethers. Now, an ether is an organic compound in which 2 hydrocarbon groups are bonded to an oxygen. You visualize it like this, where you have the oxygen as a bridge between 2 different organic chains. Now, you still name the side groups, or the parent chains that go with them, but it ends with an ether. So, for example, you're going to have a chain over here, and a chain over here. So you would have, let's say you had pentane on one side, to the oxygen, to, I don't know, methane, for an example. You would have to name these as side groups. So, pentyl, even though I don't know if that's necessarily a thing that we would talk about, and methyl. So, in alphabetical order, it would be methyl, pentyl, ether. And next we have the 2 that go together because they're basically the same thing, aldehydes and ketones. Now, Aldehydes are both organic chains with a carbonyl group on a carbon somewhere in the chain, but the difference is an aldehyde has it on a terminal carbon, which is one of those ones on the end of the chain, and a ketone is one that has it on an interior carbon, or one of the carbons in the middle of the chain. The difference is, for an aldehyde, you have an Al ending. For a ketone, you have an ONE ending. And there are a couple of these, like we talked about last time with benzene, that have other names, like methanal is what used to be called formaldehyde, propanone is acetone, which are probably familiar. These can be used as preservatives, or in plastics, or as a solvent, or maybe possibly odors or flavors. But in order to look at a carbonyl group, you would have, for an aldehyde, where it's on the end, you would have the organic chain, then the last carbon double bonded to an oxygen. For a ketone, you would have it this way, or you'd still have another hydrogen here, just for the specific example. Now this is another one where you will need to put in position numbers to tell you where the carbonyl group is, because it doesn't necessarily have to be at the end, but only if it's in a ketone. Aldehydes will never have the group, because you know that if it's an aldehyde, it is on a terminal carbon. Next, we have carboxylic acid. Now, carboxylic acids are organic compounds that contain a carboxyl group on a terminal carbon. Now, the carboxyl group formally looks like this, which is basically part of a carbonyl group with a hydroxyl group on it. These are used as buffers, or weak acids, or possibly even food additives. The only difference is when you're naming it, if you see this, it'll have an oic acid ending, like for example 1, 2, 3, 4, 5, and then you have this here, pretend all the hydrogens are filled in, 1, 2, 3, 4, 5. This would be pentanoic acid. Now, after this, we have the esters group. Now, the esters are organic compounds that contain a carboxylic acid group where the H of one of the hydroxyl group is replaced with an alkyl group. Now, that is a very long-winded way of saying it looks like this. We have two different chains connected by the oxygen here, and this carbon at the end of this chain is double bonded to an oxygen. So if you look at it this way, you have the carboxylic acid group, except you have an H here. The H in the hydroxyl group was replaced by another organic chain. In this case, I just wrote an R. These, when you name them, have the O8 ending. That's the whole thing. So if you have 4, where you have, that is butane on one side, ethane on the other, imagining that all the hydrogens are filled in. Now since this side has your double bonded oxygen, this becomes your parent chain. So butanoate, and this becomes naming like a side group. So you would say, in this case, it's ethyl butanoate. This does not need a position number because it's going to be on the side of this oxygen no matter where it is, and since this has to be on the end of the chain, it can't change. The last type of group to talk about is an amine group, but these are pretty easy. If you remember from bio talking about amino acids, functional groups, which you briefly mentioned, which might start to come back to haunt you. An amine group is basically an organic chain containing a nitrogen group. It'll look something like this. It'll have a chain coming off the top, and whatever your parent chain is, your side group's your parent chain, you follow it up with amine at the end. And this should conclude episode 19 of Chemistry in 15 minutes or less. Feel free to leave questions or suggestions in the comments below, and be sure to follow the in-video links, check out the playlist, or head over to my channel for more videos on chemistry review. And as always, I hope this is helpful, and have a great day.